Good morning to one and all. Welcome to the GPREC Center for Digital Education of E-Content Development Program on the module Concrete Technology subject. So, in today's lecture, we are going to be discuss on the lecture number 2, Admixtures Part II. Okay. So, before entering today's program, let us introduce myself. I am M. Hemant Kumar, working as an assistant professor in Civil Engineering Department from G. Pullareddy Engineering College, Autonomous, Kurnool. In the previous sessions, we have discussed some of the topics that is on admixtures, introduction, and their importance and advantages. And in today's program, we are going to be discuss on the types of chemical admixtures and types of mineral admixtures. Now, coming to the chemical admixtures. Okay, now basically what is mean by an chemical admixture? This is an admixture. It will be available in liquid form. What are the mineral admixtures? Mineral admixtures are available in powder form. Nothing but solid particles, liquid particles. Okay, so this liquid form of admixtures, where we can use, we can replace in water. Okay, the liquid form of chemical admixtures will replace in water, which improves the workability levels. Okay, and it improves or changes or improves the setting time and to improve the high strength. Okay, so don't be confused here. Admixtures will have two types. One is chemical admixture, another one is the mineral admixture. These chemical admixtures, it will be available in liquid forms. So the liquid form, okay, the liquid nature of a particle, it will be replaced in a concrete, nothing but the water. If the water scarcity is there, then go for the chemical admixtures. Okay, so while using these chemical admixtures, what it will be happen? We can improve the workability level, we can change or increase the setting time, nothing but the accelerators and retarders we can use. Next, high strengths. Okay, so now coming to the part. So there are having some different types of chemical admixtures are there. What are those types of chemical admixtures? First one, accelerators. Okay, what is mean by an accelerator? Accelerator admixture will speed up the setting time and it used to gain the strength of a concrete member. Okay, next, nothing but these accelerators will be used in cool or rainy weather conditions. Next, retarders. Retarders also one type of an chemical admixture which is used in the concrete material. So it delays the setting time. Accelerator means the name only it is there. Accelerator. Accelerator means which improves the speed. It changes the speed to speed up the setting time and to increase the strength. For example, small example we will be discussed. Now today I have to travel for the temple. Okay, I have to travel for the temple. So I'm having very less time. In between there are having number of vehicles, full traffic is there. So in that one, if I'm going to be accelerate my vehicle, so the speed will be increase and I will reach the temple in time. I will reach the temple in time. So that is the concept of accelerator in the vehicle or else in the bus or else in the car. Okay, if we increase the accelerator, our vehicle will move speed. Same as it is, if we use the accelerators, it will be speed up the setting time. Okay, the accelerators will be used only in the rainy weather conditions and winter weather conditions, or else any bridges or dams also. Okay, done. Coming to the retarders in the summer season, in the hot weather conditions. Okay, coming to the retarders, it will be used mostly in the hot weather conditions. Why? Because if we are going to be manufacturing the concrete, we are placing in any specific location, nothing but slabs or beams or any long columns or pillars or piers. What will be happen due to the hot weather? Suddenly, due to so during in the transporting process, it will going to be set. So it will be having very disadvantages. So to reduce the setting time, I'm going to be retarders. See here, accelerator, retarder. Accelerator is which is to speed up the setting time. Retarder is to reduce the setting time in the hot weather conditions, useful in the hot weather. Okay, next, water reducers. Water reducers means nothing but if there is availability of a water very low, then I will go for the water reducer. Okay, done. For example, sir, near my city or near my town, sea and the ocean is there. From there I can get the water. No means why? Because the water it contains. Sorry, wait. The water it contains salt contaminants. Salt contaminants means nothing but in the sea water, in the oceans, the water it contains salt contaminants. So the sea water it won't be used for the, should not be used for the constructions. Okay, so the water it is available on the rivers. Okay, if the water is available on the rivers, that one we have to be considered. Sir, for example, beside my city, beside my town, the river water is not there. I have to get from the trucks from the long distance. So the water scarcity is very critical is there. What I have to do as an engineer, we have to give the suggestion, okay, reduce the water content, then go for the water reducer agents. Those are chemical admixtures. See, so to reduce the water content, it should be required to achieve the desired workability. Sir, if the water content I am going to be reducing, the workability of concrete, it will be having small changes, no sir, and it improve and it won't be improve the strength, no. So for that one purpose, there are having two types of water reducer agents. One is plasticizers. Second one is super plasticizers. So what is the differences between plasticizer and super plasticizer? Nothing but, for example, for the nominal concrete, for the preparation of nominal concrete, you will take 7 buckets of water. You will take 7 buckets of water. Okay, so these 7 buckets of water I can reduce 6 and I will use only 1 bucket and I will add plasticizer. Okay, I will add plasticizer. See here, in those 7 buckets I am reducing 6 buckets and I am using only 1 bucket of water plus plasticizer. Okay, that is plasticizer. See, reducing water demand and improves the workability. Coming to the super plasticizer, so in the 7 buckets of water, I'm not at all taking. I'm reducing 7 buckets. I'm using only super plasticizer. Just some small quantity, either 200 ml or 250 ml or 300 ml, depends on the mixed design proportions. We have to be add that super plasticizer. I am not at all taking the water, entirely 0 buckets of water. 0 bucket of water I am taking. See here, from 7 buckets I have reduced to 6 buckets and I am taking only 1 bucket of water. For that one I am adding only the plasticizer. Workability will come. Sir, water I don't want. So then reduce 7 buckets. Don't take the water, just to go for the super plasticizer. Sir, the super plasticizer, some cost is some little bit high. Then take the mixed proportion as a balanced manner. Okay, nothing but a half bucket of water and reduce the super plasticizer. If you are taking super plasticizer more, the workability of concrete will have very difference. Okay, you can't. So if you are going to be placing, there will be having bleeding, segregation. These are the two major factors which will be defect from the concrete after placing in the molds. So these are the two water reducer agents. Okay, when the water scarcity is there. So the plasticizers, which is used to reduce the water demand and improves the workability. Coming to the super plasticizers, it significantly improves the flow ability of a concrete. Okay, to reduce the high level of water, we can go for the super plasticizers, and also it improves the good flow ability of a concrete. Okay, now air entraining admixtures. What are those air entraining admixtures? Nothing but these are the chemicals added to concrete to introduce millions of tiny uniformly distributed air bubbles during the mixing process. So these air entraining admixtures will be used for self-compacting concrete to reduce the air bubbles. Okay, air bubbles means air voids. After after placing that concrete in the mold, so there will be after having the compaction process, some small little bit air voids will be provided. To reduce those air voids, we can go for the air entraining admixtures. So for that one, the special type of a concrete we can going to be prepare self compacting concrete. No need to do the compaction process. Selfly it will be get compacted after placing in a mold, after placing in a location, specific location, nothing but slabs, beams, columns, anything areas. Okay, next. You people are observing, these are the chemicals. These are the different types of admixtures. What type of admixtures? Chemical admixtures. So these are the chemical admixtures will be used for the during the mixing or before the mixing, during or before the mixing the process of concrete. Okay, so how? Sir, sometimes these are the chemical liquids, it won't be available. So this chemical admixture we have to be prepared 24 hours before. So before the concrete mix, we have to be prepare this chemical admixture. Okay, how? If it is available directly in the liquid form, directly go for the mixing process. If it is available, if it is not available in liquid form, it will be available definitely in small capsules or powder, small capsules. So these capsules, nothing but small like our medicine tablets, it will be there, no, or also small stone particles, it will be there, no, like that it will be available. So add some kind of acid. For that one, reaction purpose, we have to add the acid. Then the kind of admixtures, chemical admixtures, it will be formed. So then the kind of chemical admixture, nothing but in the liquid form, it will be changes, reaction it will be having. Okay, so these are the types of chemical admixtures. Now we will go for the accelerators. See, now coming for the chemical admixtures. So the chemical admixtures, accelerators are chemical admixtures used to increase the rate of hydration of cement, thereby to reducing the setting time and increases early strength of a concrete. So what is the purpose of accelerator? So to speed up the initial and final setting of concrete and to increase the early strength gain and to enable early removal of the formworks, and it will be used in cold weather conditions. Okay, what are the common types of accelerators are there? Nothing but calcium chloride. Okay, now you got the idea. Sir, you are telling that accelerator is there, retarder is there, but what are those chemical compositions? Nothing but the accelerators are calcium chlorides. Okay, CaCl2. So if you go for the shops and ask the calcium chloride chemicals, so they will be provided. So just to take, if it is in liquid form, directly add in the mixing process. Okay, next, second one, non-chloride accelerators. See, for calcium chloride, most commonly used accelerators, very effective in increasing early strength. Okay, how much dosage we have to be provided? 2% by the weight of cement. For example, if you are taking 500 grams of cement, okay, so the dosage means 1 spoon or one small bowl. How much quantity, that I don't know, but I have mentioned here 2%. How 2%? By the weight of cement. What is the weight of cement? 500. So in this one, 500 into 2 by 100. How much it will be get? 2 into 5. 5 into 2, 10. So 10 grams of 10 grams of calcium chloride will be added. It will be converted into the ml. Okay. So like that we have to get calculation in the mixed design process. Next, non-chloride accelerators also provided. That is calcium nitrate, calcium formates, next sodium thiocyanate. So these are the different common types of accelerators. Now you got the idea of accelerators. Now come to the retarders. These accelerators used for where reinforcement or pre-stressing steel is present. Now coming to the retarders. So retarders also one of a chemical admixtures which is used to delay the setting time process. Okay, purpose. So to delay setting time of concrete, to maintain the workability for a longer period, and to prevent the cold joints in the concrete, and suitable for the hot weathers. Okay, now common types of retarders. Now we have discussed for accelerators, what are the types of accelerators will be available. One is calcium chloride, another one is non-chloride accelerators. Now coming to the retarders, one is calcium sulfate, which is gypsum and sugar derivatives and lignosulfonates and hydroxycarbolic acids and phosphates. So these are the common types of retarders will be available. See here, you just read the names. Already we have heard in our chemistry subject. Okay, so if we go in any chemical shops, if we ask the calcium sulfate, sir, gypsum is there, gypsum it will be available in the powder form, then I want to be add in the retarders. No problem, directly you can replace in cement, or else if you want to prepare the chemical admixture in the liquid form, just add some kind of acids or bases, okay, for having the reaction process. Okay, next, sugar and sugar derivatives, lignosulfonates. Okay, these are the different kind of chemical admixtures in retarders. Now plasticizers also one of a chemical admixture which is to reduce the low water content. Purpose: improves the workability and flow, reduce the water cement ratio and increase the strength and durability, improves the surface finish, reduce the segregation and bleeding. While using the plasticizer, the main purpose of a plasticizer is these are the conditions will have changes and improves. See here, we can reduce the water cement ratio and also increase the strength. If we increased strength will be happen easily, durability also increase, reduces the segregation and reduces the bleeding also there. Common type of plasticizers. See, in the accelerators there are having calcium chlorides, and for the retarders there will be having lignosulfides next to sugar and sugar derivatives. Okay, in the plasticizers, what are the common types of plasticizers are there? Same as it is, lignosulfonates, hydroxycarbolic acids, sulfonated polymers. Okay, next, plasticizers are also called as normal water reducers. Okay, water reduction capacity will reduce by mixing 5 to 10%. So the dosage it will be having 5 to 10%. No problem, you can take 20%. For example, you are getting the water 197 liters. Okay, then how much quantity of plasticizer that you are going to be adding? For example, 10% means nothing but addition of plasticizer, that is 10%. How? 197 into 10 by 100, 19.7 liters. So we have to be convert into the ml. Okay, so this 19.7 liters of chemical admixture plasticizer should be added in the water. Then how much reduction will be there of a water content? Simple, 197 minus 19.7. How much it will be get? Nothing but 0, for example. So 177.4 something it will be get. So the water which will be taken as 177 liters and the plasticizer will be taken as 19.7 liters. So like this we have to be take plasticizer and water. Okay, sir, I want to be improve the plasticizer, go for the 20, no problem. So then the calculation will be taken as how? 197 into 20 by 100. Just you do like that one and do the calculation part, convert into the ml. So like this the process will be done. Okay, next, super plasticizers. Super plasticizers means no need of taking the water. Okay, see, a super plasticizer is also one of a chemical admixture which is used in the concrete to increase the more workability and significantly total reduction of the water also, and this is also known as high range water reducer, HRWR, high range water reducer. What is the purpose of using these super plasticizers? Nothing but it produces high workability and it improves the good flow of a concrete. Okay, if you are constructing very large tall pillars, piers, columns, okay, and large structures, then we can go for the super plasticizers. Why? Because there will be having good flow ability of a concrete and it achieves the high strength with low water cement ratio. What is the water cement ratio? Okay, this is a range of workability. What is the range of a workability? Nothing but 0.4 to 0.6 for the standard nominal concrete. For example, if you want to take 0.4 or if you want to reduce the 0.4, 0.38 you take water cement ratio, then add this super plasticizers or plasticizers, then you will be achieve very good strength of that concrete member. Okay, it improves the durability also. Mostly the super plasticizer will be used for the self-compacting concretes, for the large type of concretes. Okay, now we will see what are the common types of super plasticizers are available. See here, SNF, nothing but sulfonated naphthalene formaldehyde. Next, SMF, sulfonated melamine formaldehyde. Next, polycarboxylate ether, and the reduction of water 20 to 30% is there. So 20 to 30% of dosage we can add. Nothing but the reduction of water will be having 20 to 30%. Okay, next, comparison between plasticizer and super plasticizer. See, parameters, water reduction. For plasticizer we can take 5 to 10%. Coming to the super plasticizer, 20 to 30%. Next, workability level, it will be having good and moderate level, and also high. Coming to the super plasticizer, it is having very high. Next, cost, very low cost. Plasticizer will have very low cost. Coming to the super plasticizer, some little bit higher. And the plasticizer we can use for the type of concrete for normal RCC, but for the super plasticizer for high strength concretes and self-compacting concretes. Okay, done. Relevant IS codes we can use for these admixtures. What are those IS codes? Nothing but as per Indian standard IS 9103-1999. Those are the, so that is IS code for specification for concreting admixtures. So for the preparation of RCC structures, we can use IS 456-2000. Use of admixtures in concrete. How much dosage, how much, what type of admixture we can use for the concretes, that one topic. Okay, code book. Next, coming to the mineral admixtures. So there are having mineral admixtures. These mineral admixtures are extracted from industrial wastage byproducts. It will be available in powder form. See here, what is this? What is this very black? It is looking like a soil. That is not a soil. RHA. What is RHA? You heard the word, this one, rice. Rice means daily we will eat. That is one item. Husk. In Telugu we say pottu. Okay, biyapu pottu. Rice husk. Okay, so there will be having the brown color shell, like a small brown color cover. Okay, so collect that rice husk and get it fire. Finally it will be become like this powder. This type of a powder is calling as rice husk ash. Natural material, no, groundnut shell ash, one of an example of mineral admixtures. Natural mineral admixtures or rice husk ash, next fly ash, and next groundnut shell ash, next this one sugarcane buggage ash. These are the different ashes we'll get naturally, but from the industries we will be get fly ash, GGBS ash, silica fume ash, metacholine ashes will be get. So mostly the mineral admixtures will be available in powder form, will be replaced in cement. It will be replaced in cement. Okay, see, so what are the mineral admixtures are there? Number one, fly ash, very highly available. Okay, so this fly ash, it will be get extracted from extracted from thermal power plants. Coal thermal power plants. So this fly ash will be extracted from thermal power plants. Okay, so it improves. What will be happen, sir? What will be happen, sir, while adding this? What will be happen while adding this mineral admixture, that is fly ash? Nothing but to improve the workability and long-term strength. Next, GGBS. What is GGBS? Ground granulated blast furnace slag ash. GGBS ash. So where it will be get extracted? From the steel plants, steel manufacturing plants. This GGBS will get extracted from two types of steel. One is from steel, another one is from iron. Okay, from aluminium also it will be get. Okay, that is red mud from aluminium. From the aluminium factory also, the wastage byproduct will be get red mud ash. So the red mud ash also we can use as a mineral admixture. See, so what the purpose of adding the GGBS? It enhances the durability and reduce the heat of hydration. Next, silica fume. So silica fume, it will be extracted from the silicon industries. So it increases the strength and reduces the permeability. Permeability means nothing but to reduce the air voids. Next, metacholine. So metacholine, it will be improves finishing layer and reduce the efflorescence. Okay, now we will see some of the images. This is fly ash. See, you people can observe it is extracted from the coal thermal plants, power plants. GGBS, it is very having white color. So these are the GGBS. It will be extracted from the steel manufacturing and iron manufacturing plants. Next, silica fumes. Next, metacholine powders. Next, rice husk. So rice husk, it is a very natural product. Next, POFA. Okay, next, so some kind of natural products we can take and just keep on the fire or else just burn. Finally it will be changed as into a ash mode. Okay, done. Fly ash. Fly ash is a pozzolanic material obtained as a byproduct from coal-based thermal power plants. Okay, it is used widely as a partial replacement of concrete and mortar to improve the performance and sustainability. How fly ash works? First, it will react with the calcium hydroxide, that is CaOH is taken to during the cement hydration. Definitely we are going to be taking that cement. Okay, this one replacing of cement. I am going to be adding fly ash. How this fly ash is going to be working? So in the cement content, one of a major chemical composition is there, that is calcium hydroxide. CaOH is taken to. So this will be having reaction. So then the slowly working will get starts. Nothing but it forms the formation of CSH, calcium silicate hydroxide gel. It will be formed as a CSH gel and it having results in denser and stronger concrete over time. Next, what are the chemical compositions will be provided in this fly ash? One is silica, alumina, iron oxide, calcium oxide. Okay. Next, see how the extraction of this fly ash will be get from the thermal power plants. Solid waste, fine gray, and again it is going to be recycling. Next, types of fly ash. According to the as per Indian Standard Code IS 3812, class F and class C fly ash will be available. Class F, it will be having low calcium, purely pozzolanic and used in mass concrete and durable structures. Coming to the class C, it is having high calcium, nothing but the bonding strength. If you are taking class C fly ash, it is having the high calcium, it provides a good bonding. Coming to the class F fly ash, it will be having low calcium. Next, both cementitious and pozzolanic material and faster in early strength. So by comparing here class F and class C, obviously we can say class C is the good product of fly ash for the replacement of cement. Next, for the silica fume. Silica fume is a highly reactive pozzolanic material obtained by product of production of silicon or ferrosilicon alloys in electric arc furnaces. It is also known as microsilica. Okay, so the silica fume isn't directly from a single plant. It's a byproduct of industrial processes making silicon metal or ferrosilicon alloys using quartz, coal and wood chips as a raw materials. See how silica fume works. Pozzolanic actions. It will be reacts with calcium hydroxide, same as it will be formed as a CSH gel. Microfilling effects. So it will be fill voids between cement particles, making concrete very dense. This is a flowchart. You people can understand how the silica fume will get extracted from the industrial by wastage product. See the raw materials. What are the raw materials? Carbons like coke, coal, wood chips, quartz. It will be collected. Okay, it will be collected and dumped into the furnace. Okay, during the 2000 degrees of temperature, it will be get heat. Here the silicon material will be get. Okay, silicon material will be get. So due to the off gas, the baghouse filter as produced silica fume, it will be provided. Okay, next, chemical compositions. In the silicon dioxide, it will be present 85 to 98%. And what are the minor amounts of chemicals will be present in the silica fume? One is Al2O3, okay, aluminium trioxide, Fe2O3, okay, ferrous trioxide. Next is CaO, calcium oxide. So these are the major chemical compositions which will be available in cement also. But why we are adding this mineral admixtures? To reduce this cement. Okay, my dear students, to reduce this cement, I am going to be taking. So it should be satisfied the cement properties. See, now I am taking the silicon fume. What are the chemical compositions will be there? Same as equal to cement. So then it is satisfied. Okay, same as reactions are having in cement, it is satisfied. Then I can use for the replacement of cement. For example, some different small powder form means in our mind first we will get Pond's powder, okay, or also Santur powder. That one also one of a powder, no, we can use, no. But in that powders, these kind of chemicals will be present, no. It won't be work. If we are going to be using, the chemical reaction will be having different. In the different, very dangerous is it will be there. Damage of concrete member. Okay. So when we are using the mineral admixtures, those mineral admixtures get the satisfied result and same as a cement. Then only we have to move. Okay. Done. Special concretes with admixtures. One is high strength concrete, high performance concrete, self-compacting concrete, ready mix concrete. So the admixtures that I have mentioned, for the high strength concrete, what are the admixtures we can use? Super plasticizers and silica fume. Okay, see here, chemical admixture is there, mineral admixture also is there. Purpose: reduce the water, increase the density, increase the compressive strength. Coming to the high performance, these are the special concretes. We will be take some different lectures. Okay, some different session we will be take for the preparation of special concretes. Just for small sake, I am telling now. Okay, so next for the high performance concrete, same as super plasticizers, retarders, mineral admixtures for having purpose high durability, low permeability, and high workability levels. Okay, next self compacting concretes. PCE, super plasticizers, viscosity modifying admixtures. Next purpose: no vibration is needed. Okay, selfly it will be get compacted. Next, ready mix concrete, retarders and water reducers. It maintains the slump during the transportation and improves the finishability. Okay, in the most of the stages, high strength, high performance, self-compacted ready mix concretes are having major construction processes. Next, fiber reinforced concretes. Here fibers will be used, and also super plasticizers and pozzolanas. Okay, which it the main purpose to maintain the workability while adding the steel or glass or synthetic fibers. Okay, it will be helps to have a very good strength. Okay, next, lightweight concretes. Okay, air entraining admixtures, nothing but to reduce the density, improves the resistance to freeze and thaw. Next, that is lightweight concrete. Next, rapid setting or rapid hardening concretes. Admixtures will be used accelerators. What type of an accelerator? Commonly we will use calcium nitrate. Okay, purpose: fast construction. It will be used in cold weather conditions. Next, geopolymer concretes. So the geopolymer concrete is entirely prepared by chemical admixture plus mineral admixtures. Also both, we can reduce the concrete, we can reduce the cement material as usual. See, chemical admixtures like NaOH and Na2SiO2 and mineral admixtures like fly ash. Okay, sodium oxide and sodium silicate plus fly ash, we will get the reactive agents same as cement material. Purpose: we can reduce the water, we can reduce the cement and protects from carbon dioxide emissions. So one of a nature free material, geopolymer concrete. So thank you for your session, for this session.